What happens when the universe ends? The answers are way weirder and funnier than you'd expect. Let's dive right in.
You wake up for another regular day of your regular life. You feed your goat, check your phone, and take a big slurp of coffee. Nothing weird. Then you realize something terrifying. The big slurp is one of the possible fates of the universe. At any given moment, part of it could suddenly decide, nah, I'm done, and end itself. No warning, no countdown, just slurp. Imagine that happening when you're taking your morning poo. Wow, it smells like in here, Kyle. Maybe we should let the universe end, as nobody deserves to experience this odor of death. But fortunately for you, the big slurp is very unlikely to happen. Which makes me wonder, what does actually happen when the universe ends? What will be the final thing? And what will happen immediately afterwards?
Maybe the real ending isn't fireworks or a giant vacuum straw, but just quiet, like the universe slowly ghosting us, conversations left unread, or maybe it's a dramatic curtain drop, sudden and absolute. The unsettling part, we probably won't even get the courtesy of a countdown.
Well, it's time to go on another journey again. Why are you still standing there? Let's go, big boy. Conveniently, there's a spaceship right here that definitely didn't take 6 hours of setting up last night. You know the drill by now. We leave the Earth, the solar system, we exit the Milky Way, and we look at the stars beneath us. Take a good look. It's the last time you'll see them, Kyle. Let's go forward in time to the end of the universe. Wait, why did the universe die already? Should it not exist for a lot longer? Well, apparently, Kyle, we just experienced the big crunch. Everything simply collapsed into a single singularity, ready to welcome a new, grateful universe. Maybe. Turns out the universe needs to have the right amount of density in order to live and die. We call this omega, which measures how much stuff is in the universe. It's density, like how many M&Ms you can fit into your lunchbox, except in the universe, the M&Ms are made up of dark energy, the invisible stuff that makes it expand, dark matter, which is the glue that stops galaxies falling apart, and finally 5% is baryonic matter, everything humans can see, touch, or smell. Sadly for me when I met you this morning. And apparently, during our time travel, this value became greater than 1.
That's crazy complicating. The universe literally has a math exam built in. If the cosmic density number is just right, things expand forever. Too much? Everything collapses back like a badly folded lawn chair. And yeah, comparing it to M&Ms is cute, but this is cosmic portion control with dark matter and invisible energy packets, not snack food.
I guess violating the laws of physics has repercussions. But no problem, let's just try it again. Wait, it ended again? That was quicker than my first marriage. This time, there was apparently too little density for the universe to keep existing because during our time travel again, omega now became less than 1. So the galaxy stopped forming, no stars, no life, no brain rot memes. Well, that's a good thing, but the rest would suck. Everything died in a big freeze, and there's literally nothing happening anymore. I guess we learned that if omega changes by even 0.1, it can change the entire future of the universe. Let's just try this one more time and we'll take it a bit slower. And we hope that omega stays at 1. That means the universe will simply keep on going without, crunches and freezings. Okay, phew, Kyle, that worked. Let's just make sure we avoid any universe endings that prevent us from seeing the last thing to ever happen. For that, we need to ensure it keeps expanding, though, at the right rate. That value is known as small omega. -1 is the standard amount, which means the universe expands forever. We like that. He likes that. So let's try a slightly bigger jump in time. Oh, what now? Oh, small omega went below -1. I guess instead of expanding, it's gone wild. And not like the girls at spring break type of wild. The expansion accelerated so hard it ripped apart galaxies, stars, atoms, and then shredded space itself like the cheap wrapping paper you used on your cat's Christmas present.
I love the stupid analogies. Galaxies shredded like cheap cat wrapping paper is peak science comedy. It's what makes these cosmic horror scenarios oddly cozy, like bedtime stories with existential dread. So much humor and character crammed in here. Honestly, shout out to Gravipool for making the end of existence feel meme-worthy.
The universe just died by the big rip. And yes, you're watching at home, this could happen in just 22 billion years. So you better subscribe to Gravipool if you don't want to have this happen any sooner. Okay, let's start again, Kyle, because it could have been even worse. The big slurp we talked about in your bathroom, unfortunately, this would happen if small omega became even more unstable, and we definitely don't want to experience that. So we'll just hope that it doesn't happen again because we've gone through all the possibilities of the universe that end in pain, suffering, and me being stuck in a ship with you, Kyle. There's a good goat. There's only one good outcome left, and it's called the Lambda CDM model of the universe. This next attempt has to work because with this thing called the Hubble constant, we know how fast the universe expands. Technically, scientists have two values, which is making them go crazy, but we'll just hope that 68 is the correct answer so we don't die again. Because 68 means the universe's expansion is accelerating safely in a non-murderous way, unlike the Big Freeze where it expanded way too much, way too fast. Oh, thank goodness, Kyle, we didn't get slurped, crunched, frozen, or ripped. That means the universe will now end with a slow, quiet fade into nothing called heat death. Now, we can truly see the last thing that will ever happen in the universe, and what happens afterwards. Welcome to the end of the stelliferous era, the golden age of stars. This is the same era as when we left on our spaceship, but now 100 trillion years in the future, and it's coming to its end.
This is where the universe decides to just ghost everything. No fireworks, no ripping atoms apart, no surprise bathroom slurps, just an ultra-slow fade to black. Stars stop forming, galaxies go dark, and heat death basically becomes the ultimate last call. Honestly, 100 trillion years sounds insane, but Gravipool makes it feel like the universe is ending with lo-fi beats and chill vibes.
See, the golden age of stars wasn't always positive. In fact, when we were on the Earth at the start of our journey, over 90% of the stars to ever form had already formed. Tragic. But since then, the universe has expanded, and as it does, the density of dark matter has to remain the same. And so dark energy has increased too. Remember, dark energy is the reason the universe expands. More space means more dark energy. More dark energy means faster expansion. And faster expansion means everything moves away from everything. Exponentially. Like free refills for your Coke Zero if your stomach was infinitely sized. And you kept drinking because you lacked self-control. You're worse than the goat. This means that the gas required to form stars is getting harder and harder to come by because it's further away. And the most common stars to form at this point are red dwarfs who live for trillions of years, along with a few remaining sun-like stars that live for over 10 billion years before becoming a white dwarf. These smaller stars live so long that gas doesn't get put back into the universe in order to form more stars. Even black holes and neutron stars can hoard the gas to themselves in something called accretion disks, whereas large stars spread out gas fast by living short and exploding as supernova. But all of these stars are basically all gone by now. So what will happen at the end of the golden age of stars? I'm so happy you asked, Kyle. The Andromeda and Milky Way, they will collide and maybe also merge with the other 47 galaxies in the local group. Milkdromeda will stand alone as all other galaxies disappear over the horizon, and like them, will also go dim. How? Because all the precious gas, once all the stars have died, it will be locked away in white dwarfs or being chucked out of the galaxy entirely. The rest have either been fused into heavier elements or collapsed into neutron stars and black holes, never to form stars again. Some of it, however, is still locked away in red dwarfs, but even those are now dying, and will also turn into white dwarfs, Earth-sized stars with the mass of the sun and filled with compact gas and degenerate electrons.
Sounds kind of sad that the so-called golden age of stars is really just the universe burning through its inheritance early, then spending trillions of years slowly downsizing. Big flashy stars are gone, galaxies merge like awkward roommates, and all that's left are fading embers, white dwarfs clinging on like cosmic retirement homes. It's less golden, more bittersweet.
Welcome to the degenerate era, Kyle. Just like my college years, oh boy. Here though, there is no new light to replace the stars and galaxies, because the universe has expanded by 10 to the 2,554 times since you and I left Earth. Not bad, eh? And once even all the red dwarfs die, you'll be left with nothing but white dwarfs, neutron stars, black holes, and even those brown dwarfs which were never really stars in the first place. In this era from about 10 to the 14 to 10 to the 39 years in the future, you'll be drifting through a universe lit only by the occasional white dwarf flicker. Well, maybe, because they're actually cooling down into black dwarfs, which are the same thing, just without the heat and the light. Cold, invisible corpses. The real zombie stars. Planets might even still orbit some of them, but they're frozen. Galaxies are dissolving, and without fusion, the only fireworks come from rare slow-motion collisions, like maybe the non-zero probability that two brown dwarfs will slowly bump together and make a red dwarf. Maybe, if you're lucky. Because rather than 400 billion stars in the Milky Way now, it'll be like 100 stars shining in Milkdromeda. Yes, literally 100. Eventually, gravitational interactions will fling most objects out of galaxies altogether. Andromeda won't be safe either.
The degenerate era sounds like the universe's ultimate afterparty, except the lights are off, the fridge is empty, and everyone left is just corpses of stars. White dwarfs cooling into invisible, black dwarfs, galaxies dissolving like expired sugar cubes, even the occasional brown dwarf bump romance feels less hopeful, more like two leftovers clinging in the void.
And yet, this is still not the end of the universe. The black holes haven't even started their show. Now there is something called quantum tunneling. Just one more era to go through, Kyle, before we get to the final era. But this will be the longest and loneliest chapter in the universe's life. Oh, me and the goat are so excited for this. It's time for the black hole era. You're now trillions of trillions of trillions of years into the future. The stars dead. The white dwarfs frozen into black dwarfs. The universe so dark it's like trying to find the toilet at 3 a.m. in a hotel room. What's left? Only the apex predators of gravity. Supermassive black holes. And also regular black holes. Oh right, and dark matter. With no purpose anymore. And who knows if it decays or not. We can't even see that anyway, so who cares about that anymore? Other than those things, nothing else in the universe. The degenerate objects from before, white dwarfs, neutron stars, brown dwarfs, they all slowly fell into black holes or got thrown into the void by gravity, where eventually they'll fall into black holes anyway. There's no light left at all, literally just something called Hawking radiation, which is the slow decay of black holes. That's right, black holes evaporate. A black hole the mass of the sun, gone in 10 to the 67 years. A supermassive one, that's going to take up 10 to 100 years, aka a Google. Yes, that's literally where Google got its name from. And no, that cool name doesn't make their experiment of Google Plus 14 years ago okay. What was all that about? Anyway, a quick Google search also told me that some researchers did say it may be only 10 to the 78 years before all black holes evaporate. Yes, that information actually just got released. And when these black holes do die, they do so in a final flash of radiation before the real nothingness begins. By the end of this phase, even the supermassive black hole at the center of Andromeda has died. You are now in a universe with no life, no planets, no stars, no black holes, no galaxies, no nothing.
This is peak cosmic nihilism. The black hole era feels like the boss fight where even the boss eventually rage quits. Everything that ever mattered gets swallowed or yeeted into the void, and even the apex predators evaporate into Hawking radiation. That last flash before true nothingness, it's like the universe blowing out its own birthday candles and then never making another wish.
So you're probably wondering, that was it? That was a final thing in the universe? No, my dear boy, no. Remember, we're in the heat death universe, Lambda CDM. There is one more era to go, the final era. It's going to get really weird now, Kyle. Here we have stray particles drifting in infinite cold. The universe is at maximum entropy, maximum mess, and maximum disorder. There's still energy, but it's so spread out that it's basically like evenly spreading a whole tub of Nutella on a pancake the size of Texas. Well, we're now 10 to the 1,000 years in the future, and no, that's not a typo. I guess we can call it a kilo Google. And here there are only black dwarfs. Yes, they're still here, each one a carbon-oxygen corpse chilling at nearly absolute zero. That's the coldest temperature you can have. But wait, quantum mechanics says, hold my banana. One last thing happens. Yes, Kyle, it's real. This will be the last thing that happens in the universe. Remember, fusion is when two atoms of hydrogen in a star smash and merge to make new elements because of the heat of the star? Okay, quantum tunneling is the same thing, but instead of the heat of the star, it's about the pressure of the star being way too much, but it's only really for really cold stuff. And as you can see, it takes a lot longer. Quantum tunneling lets carbon atoms inside black dwarfs slowly smush together. Two carbon atoms fuse into magnesium. Nothing happens for another 100 trillion years. And now very slowly and eventually, two oxygen atoms will fuse into silicon. This goes on for a time that is way too long to even put on screen right now, right up until something called Nickel 56. And no, that's not the 56th iteration of Nickelback, the rock band, thank God, but it is radioactive, which means it decays, and when it does, it forms into iron 56. I can see the goat understands this better than you do, but this emits positrons. These are the evil opposite electrons who start murdering the other electrons and then themselves. That's bad because those degenerate electrons were the only thing holding the black dwarf together. And so the black dwarf implodes and then explodes into a full-blown black dwarf supernova.
That's epic, man. A black dwarf supernova? That's the universe's last mic drop. After literally a Googleplex of years when everything else has gone quiet, dead stars suddenly quantum cheat their way into fusing again. It's tragic and epic at the same time, the final fireworks show in an otherwise empty theater.
And no, once again, that's definitely not my favorite category on an adult website. Don't check my web history. Okay, so maybe only dozens of these supernovas will be the last things to ever happen in the universe. One last little light show, one final scream across a dead blackness that nobody sees. Except you and me, Kyle. You know, 10 to the 50 years in the future, because that's how long it's going to take for this quantum tunneling to actually happen. But here is the thing. Is there something that can maybe happen after this? Well, there is something, and it's called a Boltzmann brain. This would form from all the energy death that has happened in the universe. And there is an idea in physics that these last remaining particles form life. As in a lone consciousness that is fake memories of a life it never lived. A brain with metaphorical eyes that open for a millisecond and then vanish. Just what the actual f***? After that absurdity, yes, truly nothing. The universe stops having anything. Well, now that's done, maybe we can find a way to get to another universe. Wait, what's happening? The universe is actually creating a new one? Kyle, what's going on here?
So after trillions of years, the last lonely fireworks fade, the Boltzmann brain blinks in and out like the weirdest cosmic jump scare, and then, plot twist, a new universe sparks up. It's like the ultimate reboot, existence refusing to stay canceled. Gravipool did an amazing job with this video. The link is in the description, and who knows, maybe next time we'll dive into something even stranger. Stay nerdy.